Hello everyone, I'm Masu. Welcome to this video. In this video, I want to talk about understanding basic statistics. To learn data science, data analysis, and AI, we need to understand statistical methods and models. So, if you want to know about understanding basic statistics, please continue watching this video. Today, I'll talk about definition of the statistics and its importance, the types of the statistics, the types of the data in statistics, and what descriptive statistics are reports based on the types of the data. The first questions that mind comes to everyone's mind is, what's statistics? What do statisticians do? And what's the application of the statistic in AI and data science and data analysis? If I want to give a comprehensive definition of the statistic, it would be a statistical branch of the mathematical science that uses answers of the probability for collecting, analyzing, summarizing, interpreting, and drawing conclusions for data to help in making more effective decisions. In other words, statisticians use mathematical and statistical theories to develop methods and models to analyze data. They are also looking for precise and optimal methods for analyzing complex data to predict future observation. So, by using statistical techniques and methods, we can recognize patterns, understand trends and uncertainties, and mostly importantly, making predictions. It can be said that these techniques and methods are used in all fields that require decision making. Okay, now I believe you understood the importance of the statistic based on the definition provided. But let's take a look at the Roadmaps website to better understand the importance of the statistic in AI, data science, and data analysis. Okay, Roadmaps. Let's see. It's a website that provides a path and guidelines to learners. For example, if you like to work as a front-end and back-end developer, you can see the roadmaps for these rules. Okay, let's take a look at the roadmaps for AI, data scientists, and data analysts, to find out where statistics stand. Okay, let's see. You can see in that the AI and data analysts have need to learn mathematics and such as linear algebra, and statistics include hypothesis tests, probability and sampling. And even in the econometrics, regression and time series are statistical models and methods. Here in the coding, we need to learn Python and SQL. There's no R programming here, but R programming is good for data scientists. And in continue path, we can see exploratory data analysis, like data understanding, data analysis, and visualizations. And here we can see machine learning and deep learning and machine learning operations. I can say that machine learning and deep learning algorithms and models are statistical and mathematical models, that use statistical and mathematical theories to prove them. Okay? Now, let's take a look at the data analyst roadmaps. Let's see. First, we should know about what is data analytics, the types of the data analytics, such as descriptive, diagnostic, predictive, and prescriptive analytics, and also key concepts for data such as collection, cleanup, exploration, visualization, statistical analysis, and machine learning. And building a strong foundation that can be analyzed and reported with Excel. And here, what skills, program skills, do we need to become a data analyst? In continue these role maps, we have data collections, data cleaning, and here we have statistical techniques that are descriptive and inferential statistics. Data visualization is a subset of the descriptive statistics that I'll talk about later in the video. Furthermore, there are advanced topics include machine learning, big data, and deep learning. If we go toward learning advanced topic, we can become data scientists. Anyway, in the roadmaps of AI, data scientists and data analysts, we realize the importance of statistics in AI, data science, and data analysis because experts in these fields use statistical methods and models for their purposes. Now, let's take a look at the history of the data science to better understand its origins and how it relates to statistics and computer science. And also, how did the future of the data analysis turn towards data science? The history of the data science goes back to when the famous statistician John Tukey first wrote an article titled "The Future of the Data Analysis" in 1962, in which he described the change in the world of the statisticians while referring to the integration of the statistics and computers. With the advance of the internet and digital age, the field of the big data began to expand significantly. Many internet businesses and organizations were faced with a huge amounts of the data. They realized that data analysis helps them develop and solve many of the problems. And also data analysis help in the decision-making processes of the businesses, governments, and organizations. However, they could use traditional specialized tools, models, algorithms, and methods because in the past the size of the data sets was smaller and analysis didn't require specialized tools, models, and algorithms. Therefore, it became the reason that future of the data analysis turned toward the data science. So, it can be said that data science is a broader scope of data analysis that uses advanced tools such as SQL, Python, and R, along with a big data platform and cloud tools, and also methods such as modeling and data visualization to predict outcomes and provide insight. Essentially, data science in the integration of the statistics and computer science. Okay, now I define statistics and its importance in AI, data science, and data analysis, and also history of the data science. Now let's dive deep into statistics. Types of statistics. Statistics has two main branches, descriptive and inferential statistics. Descriptive statistics refers to a set of the methods used to summarize and describe the main feature of the data set. Inferential statistics focus on making predictions and inferences about a population based a sample of the data taken from that population. It include use data from a sample of the draw conclusion and making generalization about a larger population. This process often include estimating population parameters, hypothesis tests, and making predictions, which I'll talk more about in the future videos. As I said before, descriptive statistics is a set of methods used to summarize data patterns into informative and understandable information. It includes measure of central tendency, variability or dispersion, and distribution. The measure of the central tendency include mean, median, and mode. Measure of the variability or dispersion are range, variance, standard deviation, and in quartile range. In the next videos, I'll define each one and run them in a Python or R. Okay? Distribution includes frequency distribution and graph. A data set is made of a distribution of values shown in tables or graphs. You can summarize the frequency of the each possible values of a variable in the numbers or percentages. The famous charts that we can draw include histogram, box plot, scatter plot, bar chart, pie chart, and line chart. Okay, these measures provide an overview of the data and help identify patterns, relationships, and trends. It means that helps us to gain insights from data. Since the percentage of the descriptive statistics depends on the types of the data or the same types of the study variables, so understand the types of the data is very important, and furthermore, it helps to choose suitable data analysis techniques and tools, and also influence the choice of the visualization and statistical methods and models. So, data in statistics is classified into main types based on the characteristics: categorical or qualitative data, and numerical and quantitative data. Categorical data include nominal and ordinal data, and also nominal data includes discrete and continuous data. Okay, what's nominal data? Nominal data refers to variables that couldn't be ordered and measured, like gender, male and female, nationality, German, French, Japanese, American, and Russian, hair or eye color, like blue, brown, black, gray, and green, name of companies, mode of transportations, like car, bus, train, tram, and bicycle, or types of the cars. By the way, nominal data represent categories without any inherent order or ranking. But ordinal data refers to variables that have national order, categories, and the distance between the categories are not known. Let me give some examples, like interest level, categorized as low, medium, and high; level of education, order from primary school to PhD; level of agreement, ranging from strongly disagree to strongly agree; socioeconomic status, is classified as lower level income, middle level income, and upper level income; level of service satisfaction, from very satisfied to very dissatisfied. So ordinal data allows us to indicate the order of values, but it doesn't provide information about the exact degree of difference or distance between them. As I said before, numerical and quantitative data is classified into types of the data: discrete and continuous data. Discrete data refers to countable, individualized, and indivisible numbers. These data are typically integers without fractional or decimal components. For example, the number of the votes in an election, each vote is counted as a one discrete unit. We can't have a fractions of the votes. So total number of the votes in a discrete data. Number of the children in a family. Family can have a whole number of the children, such as no, 1, 2, and etc. This count is discrete data because we can't have 2.5 and 2.5 children, 3.2. Defective items in a batch. When inspective item for quality control, the number of defective items is discrete data. Each item is either defective or not, and you count the total number of the defective items. Number of home deliveries in a one store. Number of patients. But continuous data refers to quantitative data is a statistic that can be taken on any value within a given range. It's characterized by the fact it can be measured and expressed with precision, often include fractions and decimals. For example, height and weight. The weight or height of a person can be any value within a certain range, depending of the precision of the measurement tools. For example, a person can be 5.4 feet, 5.8 feet, 6.2 feet, and so on. Or a person can be 133.8 pounds, 156.1 pounds, and or 177.9 pounds. Salary or revenue, we can measure them with a high precision, often include decimal points. For example, an annual salary might be $50,000.50 and $70,000.90. Custom waiting times. The times customers wait for service can be measured to the seconds. For example, the average wait times might be 10 minutes, 10.20 minutes, or 11.15 minutes. The time spent on a website. Okay, I think giving an example is enough. I gave examples for each types of the data, such as gender, interest level, the number of the votes in election, height and weight, and so on. You know that each of them is a variable. So, what's a variable? Variables is any property or characteristic of an even object, person, place, or anything that can be measured and observed and take on more than one value. You know, we describe and consider several values when we want to collect data for the purpose of the research and study. For better understanding, variables are the names of the column in the Excel sheet in which we've entered values that the Excel sheet is our data set. So sometimes we can see variable types instead of data types somewhere. When a problem statement is provided, we describe variables based on the purpose of the research and then we measure and or collect them. Or if we have a database, we do data processing and data cleaning based on the variables and the purpose of the research study. So we use types of the variables instead of the data types in this research. That the types of the variables are classified like the data types you can see in this slide. So, variable types in statistics are classified in two main topics of the categorical or qualitative and numerical or quantitative variables. Categorical variables include nominal and ordinal variables, and also numerical variables include discrete and continuous variables. The examples are like the previous slide. Sometimes some people confuse types of the variables with the cause and effect relationship between variables. We have independent and dependent variables based on the relationship between variables or the cause and effect relationship between variables. For example, an independent variable can be categorical or numerical, and also a dependent variable can be categorical or numerical. We choose a model based on the types of the dependent variable that I'll talk about in the regression section, because I mentioned independent and dependent variables here so that you don't get confused with different types of the variables. Anyway, we want to know what descriptive statistics should be represented based on the types of the data or variables. Okay, first of all, we want to know what descriptive statistics we can provide for categorical or qualitative variables. For example, we can calculate the means of categorical variables or data. We can show distributions such as frequencies or percentages for them. So we can calculate and provide frequency, relative frequency, cumulative relative frequency, and graphical forms for categorical variables. That frequency is accounted of the number of the occurrences of each category. Relative frequency is a proportional percentage of the observation within each category. Cumulative relative frequency is the sum of all relative frequencies that refer to the combined percentages of the given and perceived value in the distribution. For graphical form in the categorical or qualitative variables, we can show them with a bar chart and pie chart, which provide visual representations of frequency or percentage of each category. But what descriptive statistic can we provide for numerical or qualitative variables? In the numerical or qualitative variables and data, we can report measure of the central tendency, measure of variability, and distribution. Measure of the central tendency include mean, median, and mode. Measure of the variability include range, variance, standard deviation, and in quartile range. Distribution shows graphical forms such as histogram, box plot, scatter plot, line plot, and stem and leaf plot. Okay, I think that's enough for today. In the next video, I'll run everything I talked about in this video on Jupyter Notebook and all so that you can understand them better. Alright, thank you. Thank you for being with me and supporting me.